Assalamualaikum. Okay, we are going to learn today factors affecting resistance. Okay, the resistance of a conductor is a measure of the ability of the conductor to resist the flow of an electric current through it. From the formula, Ohm's law formula, V equals to IR, the current I is inversely proportional to the resistance R. When the value of the resistance R is large, the current I flowing in the conductor is small. So what are the factors affecting the resistance of a conductor? So we have length, cross-sectional area of the wire or diameter of wire, and material of wire, and temperature of the conductor. So we have length, cross-sectional area or diameter of wire or thickness of the wire, material of wire, and the temperature of the wire. Okay, let's say we have two circuits, circuit A and circuit B. Circuit A, we have the conductor wire of length 20 cm, while circuit B, the length is 60 cm. So the current I is flowing 1.4 ampere and potential difference 2.0 volt. So the resistance for circuit A is 1.3 ohm. So the wire used are of the same material and thickness but have different lengths. So calculate resistance for circuit A and circuit B. So we calculate just now. Circuit A has 1.43 ohm, while circuit B has 3.1 divided by 0.7 should be 4.43 ohm. So circuit B has larger resistance because of longer conductor. So the length of wire influence the resistance of wire. The longer the wire, the higher the resistance of wire. Length of conductor, so the higher the length, the higher the resistance. So length of a conductor is directly proportional to its resistance. Okay, secondly, we have another information. The diameter of wire is shown by the unit SWG, stand for standard wire gauge. So we have the number 24, 26, 28, 30. Okay, so for example 24 refer to 0.599 millimeter and so on. One thing is the higher the number from 24 to 30, the wire will become thinner. The thinner the wire, again the higher the number, the SWG number, the thinner the diameter. We have another two circuits, circuit M and circuit N. This time conductor wire of the same length, but the wire with SW22 is thicker than the SWG30 wire. So this time we change the diameter of the wire. We fix the length of the conductor. So calculate resistance for circuit M and N. Okay, for circuit M, resistance is 2 divided by 1.4 should be 1.43 ohm. Well, circuit N should be R should be 0.6 divided by 2.2 equals to 0.27 ohm. So this time inference, the thicker wire SWG22 has a lower resistance compared to the thinner wire of SWG30. Hence, more current flows in the circuit N. So cross-sectional area of the wire influence the resistance of wire. The thicker the wire, the lower the resistance. Okay. The larger the cross-sectional area, the lower the resistance. So resistance is inversely proportional to the cross-sectional area of a conductor. Okay, that is the graph. And also V versus I. So when we look at there are three types of wire. SWG32, we see the fine wire, medium SWG26, and the thicker wire SWG22. Then the thicker wire has the smallest gradient, means that it has the smallest resistance, while SW32 is the thinnest wire and it has the greatest gradient and the greatest resistance. Okay, so now we have three types of circuits. This time, what is the difference? Wire are of the same length and thickness but different materials. So we have circuit P constant wire, circuit Q nichrome wire, circuit R copper wire. So we calculate the resistance for each wire, each circuit. So P has 1.43 ohm, Q has 3.38 ohm, and R has 0.09 ohm. So we have the lowest resistance. So the copper wire has the lower resistance. Okay. So nichrome has high resistance while copper wire has lower resistance. So the resistance also depend on the type of material of the wire. So when we plot the graph V versus I, so nichrome had the highest gradient, so it has the highest resistance, while silver has the lowest gradient, means has the low resistance. So resistance of conductor change with the type of material of the conductor. The last one is temperature of conductor. The higher the temperature of conductor, the higher the resistance. So resistance directly proportional to the temperature of conductor. Okay, quiz. Okay, which of the following pieces of copper wire has the greatest electrical resistance? Okay, so length, the higher the length, the higher the resistance. So either C or D. But diameter should be thinner. So I choose C. Alright, correct. Okay. So resistance of wire directly proportional to its length but inversely proportional to its cross-sectional area. Okay. A long and thin wire has higher resistance. A short and thick wire has lower resistance. Okay, question 2. X and Y are lamp with filaments made from the same material. Okay, same material. X is thicker but shorter than lamp Y. So when the beam supply is switched on, which is the brighter lamp and which has the larger resistance? Oops, brighter lamp with which has the larger resistance. Okay, which one is the answer? So larger resistance should be what? I think should be Y, right? Right. So brighter lamp should be X. Okay, because current flow, more current flow in X because lower resistance. Okay, the filament in lamp X is thicker and shorter, thus the resistance of filament in lamp X is lower than Y. Increase the current flow to the film will increase the brightness of the bulb, thus bulb X is brighter. Okay. Okay, next question. A wire of length 1 meter has a resistance of 2 ohm. When the circuit is completed, the current in the wire is 3 ampere. A 2 meter length of the same wire is connected to the same circuit. What is the resistance of the wire and the current flowing through it? Okay, so we calculate. So what we get is resistance 4 ohm and the current is 1.5 ampere. Resistance directly proportional to length. So when length is double, resistance should be double. As resistance increase, current will decrease. Okay.